Okay, in this video, I'll show you guys how to solve a system of differential equations. And let's look at this right here. First of all, notice that we have both x and y, and they are both functions of time. So that means at the end, we must have x of t is equal to whatever, and y of t is equal to whatever, all right? And this is how we're going to do it. First of all, we're going to rewrite everything into the order that we like. And in this case, because we don't have the first derivative for the x and the y, this is what we want. We want to have x prime, x, y prime, y, and then everything else onto the other side. Let's do that first for both of these equations. So, first of all, notice that here we have x prime of t. This is just to emphasize that x is the function of time. But for simplicity purpose, right here, let's just write down x prime without the parentheses and the t, okay? So first, we will have x prime, and then we'll continue. I will move this to the other side, and it becomes minus 3x. And as you can see right here, we don't have any y prime, right? So I will leave a space. And then I will move this to the other side, and that will be plus 4y. And that will be equal to 1, okay? This is what we have at the moment. Next, we have this equation. And once again, we want to have the x prime goes first. But we don't have any x prime. Well, let's leave a space. Let me move this to the other side, so it becomes negative 4x. And then we do have the y prime, so I will just put this down right here, plus y prime. And then I will move this to the other side, so it becomes plus 7y. And this is equal to 10t. You must keep the t, because this means 10 times t, okay? This right here, for example, it means y is a function of time. So you can just put on y if you just remember y is a function of time. But you must have the 10 and t together like that, okay? And I like to draw you guys a left brace because I want to show you guys that these two equations are connected. We are working with them together. Next, we are going to change some notations. We'll be using the capital D for the differential operator notation. So what I mean by that is, let's look at the x together for the first equation. Here we have x prime minus 3x. The x prime means we are taking the derivative, right? And that's the d. This right here, I'll write it down as capital D, okay, for the derivative operator acting on x. And then this right here is no derivative, so I'll just write it down as minus 3. We write it down as d minus 3 with sub parentheses. And now this is an operator. This operator is working on the x, and we put it down like this, bracket x, okay? And next, I will just put down plus 4y like this. Because it has no derivative, I'll just write it down like that. And it is still equal to 1. And next, we see that we have negative 4x, no derivative, so I'll just write down negative 4x. And then the x are lining up right now, right? Once again, the x are lining up right now. Well, for this, we have y prime. That's the derivative. That means I have to have the d. So this is going to be plus capital D, and then this has no derivative, so plus 7. And now d plus 7, this is working on the y. So I'll put this down as the y like that. And this is equal to 10t like this, okay? Well, what are we going to do next? As you can see, the x are lining up now, the y's are lining up now, right? Here, it's just pretty much like the good old system of equations in your algebra class. What we want to do is, we want to make sure, let's say I want to get rid of x. I want to make sure the coefficient, that kind of thing, okay? The coefficient, the things in front of the x are the same, but opposite sign. So that I can just add the equations together and get rid of the x. That's the idea. Well, in this case, what I have in front of the x is d minus 3. And then what I have in front of the x right here is negative 4. Let me multiply the first equation by positive 4. Because this is negative 4 already, so let me just multiply by positive 4. Okay? Multiply positive 4 throughout the first equation. And then I will multiply the second equation by d minus 3. So I'll just write it down. I need to multiply this by d minus 3. Okay? Throughout this second equation. Okay? And once again, these two are, we are trying to work with them together. All right, now let's see what do we have. And the beauty of using the capital D notation is whenever we have all this right here, right? If they're just constants, then they just work like polynomials, the regular ones. That means I can just tell you, let's multiply 4 and d together, it becomes 4d. And let me just write it down nicely, it becomes 4d. Okay, 4 times d is 4d. And then I have to distribute 4 into this as well, so it becomes negative 12. And now this is the new operator acting on the x, like that. Okay? And then of course we continue 4 times 4y, and let me just write it down right here, plus 16y, right? 4 times 4y, 16y. And this is equal to 4 times 1, which is 4, like this. And for the second equation, I will do d minus 3 times negative 4. So that means I will take negative 4, multiply with this d, which is negative 4d. This is 4d. Okay, this is my negative 4d. And then negative 4 times negative 3 becomes positive 12. And then I'll put parentheses, and you see this is acting on x. So we have the bracket x like that. And the next, I will have to do d minus 3 times d plus 7. But let me just write it down as how it is. Let me just write it down as plus d minus 3 times d plus 7. Okay. And then we still have the y right here. Okay. And lastly, this is equal to, I will put down this and that. Okay. This operator, you should put it down first though. D minus 3. And then we have the 10t at the end. So we'll put this down like this. Okay. And now you see the beauty of doing so is that, oops, this is not a good symbol. Okay, much prettier. Anyways, the beauty of doing so is that, you see, okay, here are the x. The things in front of the x are pretty much the same, but opposite sign. 4d and negative 4d will cancel. Negative 12 and positive 12 will cancel. When I combine these two equations together now, the x terms will be gone, isn't it? That's wonderful, right? And now I just have to add this up together. And let me just write it down as how it is for the moment. We have first 16y. Let me just write it down. We have the 16y. And then we add it with parentheses d minus 3 times d plus 7. And then this is still acting on y. And then this is equal to, and once again, let me just put this down as how it is. Positive 4 plus this, d minus 3, and then 10t. Okay? Next, I'll show you. The beauty of using the capital D notation is that, you see, constants only. There's no t in here. In that case, we can just multiply this out, just like the regular polynomial. So I will tell you, this right here becomes d times d, which is just d squared, right? And then d times 7 is 7d, but this is negative 3 times d, which is negative 3d. 7d and negative 3d together, it will give us positive 4d. Okay? Positive 4d. And then negative 3 times 7 is negative 21. And now this is applying to y like this. Okay? So this is pretty much the new things that I'm looking at. At the end, let me show you what I mean by this. This is still 16y. Now, this is how we're going to take care of this thing. Put on the plus. Here we have the y. Just kind of do it backwards. I have d squared applying to y. D is the derivative. When you have the second power right here, right, there's the notation like that. That means you take the derivative twice. So when you do it like this, you have the second derivative y, so y double prime. And then next, you do like this. 4d applying to y, which is 4y prime. Okay, so we have plus 4y prime. And lastly, you have this, which is negative 21y. Okay, wonderful, isn't it? And then we will have this is equal to 4 is the 4 still, and I will do the same thing. D is once again to take the derivative. So let's do this right here first. I have to take the derivative of 10t. The derivative of 10t is just 10. So it becomes plus 10. And now let's do it backwards like this. Negative 3 times 10t becomes negative 30t. Okay? Just like that. All right. Now, as you can see, this is just differential equation. It's second order, right? Because you have the y double prime. But the good thing is that it has only y's, right, and also the t. Well, let me combine like terms right here for you guys first. I see that I have the negative. I see that I have the 16y and the negative 21y, and I can combine like terms. Likewise, here I can just add these two together. Anyways, let me put down the result right here. Okay, then we'll just put this down up enough so I can do the rest. So right here, we have y double prime. Let me put it down. Y double prime and then plus 4y prime. This and that becomes minus 5y, and then this is equal to 4 plus 10, which is 14, and then we have the minus 30t, okay? And now, how can we solve this? Well, you can change this to the characteristic equation, and you have the r, and then you can solve for r, and then you can find the YH first for the homogeneous situation, right? And then you have to find the particular situation as well, because we have the 14 minus 30t on the right-hand side. We can find the yp by using the method of undeterminate coefficients. And I'm not going to do that in this video. Just check the link in the description, because if I do that, I wouldn't have space. So please check the video in the description if you want to see how to go from here and solve it. I will just tell you guys what the answer is. So seriously, we can solve this. We have talked about it in the class, and I will have the video for you guys. And if you solve it, you will get y of t. This is equal to c1, which is the first constant, e to the negative 5t plus c2 as the second constant, e to the t. And you add it with 6t plus 2. This is it, okay? Notice that we have two constants, c1 and c2. And in fact, those are the constants that we need, okay, for this system of differential equations, c1 and c2. Well, you see that we only have the first order differential equation for the x, and this is also the first differential equation for y. So technically, I have one constant for the x and then one constant for the y, right, naturally speaking. But those constants happen together in here. And we will have this c1 and that c1 throughout the rest as well, okay? And now, we're almost done. Because we got the y of t already. The question is, how can we get x of t? You have two choices. Well, we got y of t right here. It's because over here, we got rid of the x first, right? So the first choice is that we can look at this right here. Perhaps we can multiply the first equation by d plus 7, right? And then I will multiply the second equation by negative 4. Okay, negative 4. I want to have 4, but be sure I want to have the opposite sign so that I can, add them up and then cancel out the y. So that was the first choice because I want to get rid of the y first, and I will be able to get a differential equation that involves just x and then solve it. But in this case, we don't have to do that, and here comes to the second choice. The second choice is that if you look at the second equation right here, we have y prime, x, y, and this is just plus 10t. Look at, we have the x right here already, isn't it? What that means is that as long as I can isolate the x, this right here, x of t will be based on y prime and y, and also just add this right here. And since we know what y is, I can just differentiate that, and I will be able to find y prime, and we can construct the solution for x of t. So let me do that right here for you guys. First of all, let me write this down. I want to isolate this onto the right-hand side, but I'll put it down on the left first. I will write it down here, okay? So we have x of t, 4 in the front still, okay? So I'm going to save this, okay? I'm isolating this right here. I want to move this to the other side. I want to move this to the other side. This right here is still equal to y prime, okay? And then I know I have the x of t, but let me just write it as y prime right here, okay? Perhaps I will just write it down as 4x because that will save me more space. 4x. Anyways, that's my 4x. Here is my y prime. I will move this to the other side. It becomes plus 7y, right? Plus 7y, and then minus 10t. Okay, this is what I have. At the end, I will just divide everything by 4. And you see that x is equal to, this right here is just 1 over 4 times y prime. And then this is plus 7 over 4 y. And then this is minus, let's reduce the fraction, which is 5 over 2 times t. Now, I'll finish this in blue so I can make this stand out a little bit. I have to get y prime, isn't it? Right? So, I'll just do like this. So let's look at this. This is y already. I'm just going to get y prime. So let's put this down in blue. Y prime of t. Well, I have to differentiate this. Let me put down c1. And then the derivative of this is e to the negative 5t. But be sure you multiply this by negative 5. And here's a small detail. We can only have c1, c2 in this situation. So do not call negative 5 times c1 to be c3. Okay? Keep that in mind. We can only have 2 constants in this situation, namely the c1, c2 that we are already using. Anyways, right here, the derivative of c2 e to the t is just still c2 e to the t. And the derivative of 6t is just plus 6. And the derivative of 2 is just 0. So this is wonderful. This is what we have. And now, here, x is equal to, we have the 1 over 4. Y prime, which is that, I have to just write it down right here for you guys, which is negative 5 c1 e to the negative 5t. And then we'll have the plus c2 e to the t, and then plus 6, right? Just like that. And then I will have to add 7 over 4 parentheses y, which is the original here. And this is c1. And we have e to the negative 5t plus c2. E to the t, and then plus 6t, and then plus 2. Okay? At the end, don't forget, this is minus 5 over 2t, like that. All right, I know it's a lot of work, but be sure you notice that all these are doable. It's just a lot of combining like terms at the end. All right, let's see what do we have so we can end up with this. All right. Let's combine like terms. As you can see, this and that together, that will give us negative 5 over 4, right, for that coefficient. And this and that will be the same term, right? And you just multiply this and that, which is 7 over 4 c1. So check this out. Negative 5 over 4 plus 7 over 4 is 2 over 4, which you reduce that to 1/2. So I will write this down in black. 1/2. Right? This and that becomes 1/2. And this term stays the same, so it's c1 e to the negative 5t. Okay? And next, you do 1 over 4 times c2, which is just 1 over 4. And you do this times that, which is just 7 over 4. This is positive 1 over 4. This is positive 7 over 4. You add them up. It is 8 over 4, which is just a 2. So I will add 2. And this is still c2 e to the t term. Okay? And this right here, 1 over 4 times 6 is 6 over 4. You can reduce that to 3 over 2, right? Well, let's see. This times that. 7 over 4 times 6. So just write this down real quick. 7 over 4 times 6. 6 over 1. Then you reduce, this is 2, this is 3. So you have 21 over 2, right? But anyways, this times that is 21 over 2t. And let me just write it down. This is plus 21 over 2t. Well, this is just a constant. That's why I couldn't combine them. But if you look at this and that, 7 over 4 times 2, this is going to give me 7 over 2, right? 7 over 4 times 2 is going to give me 7 over 2. 7 over 2, I can combine that with 3 over 2. It is 10 over 2, which becomes plus 5, right? Plus 5. Okay, once again, this and that, it is plus 5. And I still have this guy. This is still the leftover, which is the minus 5 over 2t. And guess what I can do at the end? I can combine this and that, right? So, ladies and gentlemen, I'm done. Because this right here will give me x of t, which is equal to, let me write it down, 1/2 ce e to the negative 5t plus 2c2 e to the t. And this and that I combine. 21 over 2 minus 5 over 2 is 16 over 2, which is an 8, right? So it becomes plus 8t. And then at the end, we have this 5 right here. Oh my God, look at that. Here is y of t. Let's just box that right here. And I also box the x separately. There's no other space for me to put them down like together. So usually I'll put this and that together to present the answer. But anyways, and I just want to erase this before I go. That's it!